So, welcome to the crash course for natural language processing. So, all of you are following the course. It is a vibe, and it's also a lot of information. I have tried to condense it into a kind of small crash course with most information. I have tried to also highlight some information which I remember being on the exam. For those who do not know, I have been a TA since the course started, so I think I know the exams fairly well. So I hope that these slides and the crash course will help you a lot. If you have any questions during the crash course, please raise your hand so I know that you have a question. There will be some example questions at the end of this entire crash course. For those who need to leave early, you don't need to raise your hand and ask, you can just leave. So yeah, let's get into it. I have multiple things on this entire schedule. As you can see, there's a lot of words and a lot of information. The biggest things is that at the start I will give you some more practical information, some more theoretical parts. Later in this crash course I will give you some more examples and also some calculations. So the finite state automata and regular expressions is mostly the basic stuff that you also had at the start of this course. It's kind of in the chronological order of the entire crash course. The biggest thing that I remember being a bit more difficult was the sentence probability and the perplexity and such. We will have some examples for this at the end. So let's start. Yes. So there are multiple tools. NLP, natural language processing, is mostly something to do with natural language. There's a difference between natural language and regular language. Natural language is basically something that can kind of be used as any kind of language. Regular languages are closed, as you can also see there. Finite state automata are kind of formal machine models, which you can kind of see. I think you've all had Intro to AI as certain automata which you can use. And all of these regular languages can be defined as finite state automata. So regular expressions are those search patterns that you can use on regular languages. Again, a regular language is not a natural language. Keep this in mind. They are all closed under certain sets. I will go into these, but as I said, not all languages are regular languages. So, the four principles that are closing. You have the union, you have the intersection, you have the complementary, and the concatenation. For the union, as you can see, it's if A is a regular language and B is a regular language, then anything in A or B or both is a regular language. The same goes for the intersection. If A is a regular language and B is a regular language, then anything that's in A and B is also a regular language. Now for the complement, if A is a regular language, B is a regular language, then anything that is not in A but in B is a regular language. Concatenation, anything that is in A and then followed by B or vice versa, meaning starting with A or starting with B and ending with A, is also a regular language. This might seem like a lot of random information that you might not use. I do remember that there was a question last year about this, so that's why I'm mentioning it. On to the regular expressions. These will not be given on your exam. You will have to know these. All of these are kind of important. Some of them are more important or at least more useful than others. The biggest thing to remember is that if you have a capital something, so backslash capital W, backslash capital S, that's the opposite of the normal one. So you have the alphanumeric characters, the whitespace characters, the digit characters, etc., etc. The ones that you will most likely get in the exams are the range characters, so this one, then the logical operators are 0 or 1 or more, and the OR operators. My assumption, at least, I can't say for certain. For the range of characters, this is an implicit OR. So if I, for example, have 1, 2, A, B, plus, it could be that anything that is 1, A, B, 2, 1, 1 is part of that language. So it's basically saying normal bracket or, closing bracket plus. This is something to keep in mind. I think most of you know this, but it's mostly something to keep in mind. So the difference between this specifically and another part is finite state transducers. Finite state automata do not really change a string, they're search pattern parts. For the finite state transducers, you do actually do something with the string and change it. You convert it to something else. For example, you can translate, you can make it phonetic and such, but also you can use it for tokenization, stemming, lemmatization, but also morphological processing. For these, many of them are context dependent, meaning that, let's say, I remember in one of the assignments you had to look for the definition of bank. if I just give you the word bank without any context, there are multiple options possible, but in context you can really change the string and do something with it. One of these parts that you can use FST for is tokenization. Tokenization is basically just splitting a very large string into smaller tokens. Again, tokenization. It's a very important step for pre-processing a text to make sure that you can actually use it. For example, you can make unigrams, bigrams, etc., etc. There are some slight issues specifically with alphabetic languages. Since, for example, as you can see, Los Angeles is one name. It's a proper noun. However, if we would split it into tokens, it would very often be Los and Angeles. Same goes for yesterday's news, or hey, said Bob, etc. All of these would be split, whereas that is kind of one big thing. For this one, it would be tokenized into words. For this, the tokenization of sentences would become this is a sentence and this is a sentence, but that's not the truth. Because hey, said Bob is one entire sentence compared to hey and said Bob being separate ones. Then for stemming. Stemming is just putting the entire word into a base form. Basically, you follow some strict rules that you have to adhere to. And this is not necessarily a problem if you have good rules, since you will always adhere to these rules. However, it's very crude, because it doesn't mean that you will always get words. As you see, studies, this would be seen as a multitude of a study, and then you would kind of stem it by removing the es. Study with an I, however, is not really an English word. So again, it is context-free, but not necessarily the best. It's very crude. A better one would be lemmatization if you want to have a better word. Because basically lemmatization will put your entire form into its base form in a dictionary. Keep in mind its own dictionary. The problem with this, however, is that it's very memory heavy, since it will need to look for all the possible words and then look for the base form for that specific word. So it's useful, it works very well, but if you want to make something that's kind of easy and quick, lemmatization is something that will take way more time and memory. Then for morphological processing. Morphology is something that has to do with morphemes. Morphemes are basically the smallest part of a word that still has meaning. You have two different kinds. You have free morphemes and bound morphemes. Free morphemes are basically words or things that can be on their own entirely. For example, table has its own word and is its own morpheme. However, bound morphemes are dependent. For example, possible is a morpheme, but impossible is not. The im part, however, is a morpheme because it negates possible. But it's a bound morpheme because it is, in this case, a prefix. There are other ways to create words, for example, reduplication by saying a word again to create a different meaning for it. For example, in Indonesian you have orang, which means people. Orang means person, and orang means people. So repeating it twice creates more. Another way is blending. I think you've all seen the slide where you have smoke plus fog creates smog. Again, parts of the morphemes are combined, blended, and you create a new word. Clipping is a slightly different one. You kind of remove parts of the word and create a new thing from it. In this case, let's say you could have mathematics, and that has been very often used as maths because people are lazy. And back information is one that is not necessarily very often used, but that is removing certain parts. In the English language, the word burglar, the noun burglar, has been a noun before the actual verb to burgle. So from that, what they did is they removed the affix from it and then created to burgle from it, the verb. So that's back information. This has happened with multiple verbs, but just keep it in mind, and I think all of you know acronyms, so I'm not really going into that one. And then for morphological classes, you have multiple. You have allomorphs, homonyms, homophones, and then you have some different stuff as well. The biggest part that you will need to remember is that allomorphs are the same thing. For example, as you see here, a and un both mean the same thing. They're an indefinite article. I could say a table, a car, a tree, a castle or something. It still refers to this indefinite article part. The same goes for plural. So you have the s at the end of dogs, cats, buses as well. You have the es at the end. These are allomorphs. They do the same thing. They make the word plural. Then you have homonyms. These are written the same but have completely different meanings. For example, to lead and let. These are also completely different classes. One is a verb, the other one is a noun. Then you have the ones that are right and right. I can't really pronounce those differently, but those are in regards to direction and correctness, which in this case are the same class, but they do have different meanings. For example, if I want to go right, I don't want to go in the correct. I do want to go in the correct way, but not necessarily correct. Then you have homophones. Homophones sound the same, but they are not the same. For example, cell, to trade, and cell, the thing that's in your body. Same goes for flower and flower, the plant and the actual ingredient for food. Keep in mind, these are classes that will most likely be on the exam and will be a question about what kind of thing is this, for example. Then you have the two different things to do something with words. You have inflection and derivation. The important difference is that inflection does not change the meaning of a word, whereas derivation does. Inflection basically has your word or has your morpheme, add something to it, for example, past, plural, present, etc., etc., and then you have the end thing. For example, for the verb, it's laugh, you add the past thing to it, and then you have laugh. This is not anything in regards to changing of a class, nothing changed, it's just in its basically past form. Same goes for bus, you add plural, and then you have buses, plural. Derivation, however, does change the meaning. For example, if you have the verb to create, you change it, you add, for example, IVE to it, you have creative, which now is an adjective compared to an actual verb. Same goes for empathy, which is in this case a noun, and then you empathize with someone, you add IZE, and then you have a verb. This changes both the meaning and very often as well the class. So, then on to statistical NLP. Are there any questions up until this point, by the way? Good. Oh, yes?
I don't remember the exact name, but with mathematics turning into maths and with burglar turning into burgle, you said that they're both like just shortening the word, but is the difference then that with maths the meaning doesn't change and with burgling it did?
Yes. So the biggest difference is indeed that with to burgle, you from a noun you make a verb. So back information basically means that you kind of create. Sorry, let me quickly check where the slide was. I think I'm already way past it. But indeed, there it is. So basically you indeed change it from your actual noun to a new word. Whereas indeed with mathematics, you kind of just shorten it and you kind of clip it basically. The main difference is back information creates new information, whereas clipping just keeps the same information but clips it. So, then on to statistical NLP. Statistical NLP is again just probability. This is calculations. This is very nice to do for us since AI students like probability very often, or at least not having to do it manually. And for this you can kind of see certain parts where you can kind of use sentence probability to check if certain things make sense. I believe that during your assignments, one of them was indeed check how probable this specific sentence was compared to an ungrammatical, so completely scrambled sentences. So for this you can use it in different things. You can use it for spelling correction for individual words. You can do it for machine translation, so actual translations of words, speech recognition, but also, for example, for sentence or word suggestions. Because very often, once you've typed a sentence, you will see 3 suggestions for the next word that you have. It's important that for all of this, for all the probability calculations, you need to pre-process your sentence, you need to chunk it, and you then only then you can calculate with it. How you want to use these chunks is completely up to the user. You can make it very memory intense or you can make it very light. Your actual results will differ depending on these. But all of this is based on the fact that natural or language is probabilistic. The same thing happens in ChatGPT. It just uses probabilities to suggest the next words and answer your question in this case. It doesn't really know what you ask. It just thinks, oh, this is a high probability. Let me answer this basically. So, for this you could use string similarity for actual spelling mistakes or spelling suggestion. You can use the Levenstein distance. The Levenstein distance is basically just how many kind of steps or edits do I need to take to create a other string. In this case, you have your target string in your row and your source string in your column. So Sunday and Saturday. Basically, the entire idea is you want to keep this distance as low as possible to also have other suggestions. So in this case, you see that the edit distance is 3. I think, can you all see at the bottom? Or okay, so you can see that the edit distance is 3. So for example, for Monday and Sunday, in this case, it would be the exact same thing, since both would have an edit cost of 3. So there would not really be any better suggestion. The only thing is now context, since most likely if you type Sunday, it is kind of likely that you mean Saturday because it's more in the weekend. Again, more context dependent. Then you have n-gramming. N-gramming is just, again, chunking. An n-gram is basically what kind of gram you have. You have a unigram, a bigram, a trigram, a quadgram, etc., etc., etc. All of these basically just means how large is your chunk that you're looking at. Is it 1 token? Is it 2 tokens? Is it 3 tokens? 4, etc. For this, you do need to very, very, very carefully pre-process your sentence. For this, you need to first remove the start of the sentence and replace this with the hashtag. This basically also puts everything into lowercase in regards to start sentence parts. So my dog ate some food will become hashtag my dog, etc. The end of the sentence goes the same thing. This time you change it to EOS, which means end of sentence for those who do not know, and you put that at the end of the sentence and remove that full stop or your token in this case. If you have multiple sentences after each other, you have hashtag sentence EOS and again hashtag since you start a new sentence. So this is for all of them. Then for sentence probability, this is what most people have been struggling with and also something that will be on your exam. So sentence probability can be basically calculated by looking at the combination of all the words in your entire sentence. The way you do this is again dependent on how you want to do this. Do you want to do this by unigram, bigram, trigram, or anything that was before this word? That's completely up to you. However, very often this will become very memory heavy, so we have made use of the Markov assumption that any word is only dependent on the word before it, the bigram approximation. This will also, I believe, be in your exam, but not be mentioned explicitly, so keep in mind it's very often that you have to do it just by bigrams. Basically what you do is the probability of a word given any word before is the probability of all the words occurring over just the 2 words occurring that is given by. This can also be seen as counting the words. So this is roughly the same. This is what we just used because that's way easier than having to calculate it. You count the occurrence of these 3 words occurring together in this order divided over these 2 words occurring together in this order. So basically it just means that what you do is you count words, you check, divide it over the other words, and then you have your probability for, in this case, your trigram. Yes?
So if the order is different, then we wouldn't count them?
No.
So if we have the same 3 words, but just the order is different?
Yeah, so for example with the sentence before, my dog ate some food. If I would say, I want to check what the probability is of 8 given my dog, what I would need to do is count the occurrences of my dog ate in that order, divided over the occurrences of my dog. The reason for this is otherwise you would have the ungrammatical sentence as I explained before, because logically the amount of times dog my ate is way less likely than my dog ate. So that's why you need to count also specifically in that order. Does that answer the question? Good. So, bigram approximation. You see many things which looks like a formula. Fun. You do need to remember this. I'm very sorry. This will not be given in your exam. This is basically just how can we do the entire thing. So given a sentence, we will always use, because it's less memory heavy, the bigram probabilities. However, the problem with this is if we do this in normal space, you will get very small numbers, and that therefore if your calculator sees too many small numbers, it might lead to 0. Next to this, again, 1/0 probability times anything else means 0. This is just basic maths. If you do this in log, however, you will get a kind of easier thing. If you have the natural log, this is important. I believe that in the slides it's just that log. You need to use the natural log. So basically you have e to the power, and the inverse of that is the natural logarithm. keep in mind, people made this mistake more than you think. So basically this is again for the unigrams, since for bigrams it was way too much to write for me. So for this you just have the entire logarithm of the entire probability is instead of multiplying, adding it. This is again just basic math rules. If you have the multiplications or certain things, you can also put them into logs and then add them together. This is just a mathematical step. This is just something to keep in mind. I would really advise you to do it in log space. The reason is you have way more understandable numbers and you see way more easily if you make a mistake. And if you need to, again, inverse it to an actual normal multiplication thing, you can still do e to the power of the entire answer you had, and it's again fixed. The inverse of your probability is perplexity. Perplexity is just how surprised am I by seeing this specific sentence. If I see a certain sentence and I'm again very perplexed by it, it's not very good. So minimizing your perplexity is maximizing your probability. This kind of comes back to the question you had. The perplexity of dog my 8 is very high compared to my dog 8, since it's very unlikely, meaning the perplexity is high. So this formula you do have to remember. It will not be given in your exam, and perplexity, I believe, will be one of the questions. It's not necessarily a super difficult one to remember, it's just something to keep in mind for yourself. Then, for smoothing. Basically, smoothing is just making sure that any probability you have, you can also actually use. Since it can, basically, will occur that certain bigrams, trigrams do not occur in your training corpus. If my training corpus does not have the word, let's say, dog or dog 8 in my entire corpus, it will be 0. And again, multiplying anything by 0 will become 0. Smoothing just ensures that you do not have a 0 probability. One of these ways is making use of Laplace smoothing. Laplace smoothing just means adding 1 to everything. So in other words, you have adding 1 to everything means your vocabulary size, so the different words that you have, the length of that, you add that to your denominator, the bottom thing, I don't know which of the two is the numerator, and then you add 1 to your top thing, I believe that's the numerator. So basically that just means that you will have a non-zero probability. Because again, let's say that the word table does not exist in my entire training corpus. The top part would be 0 and then divided by anything, which would lead to 0. But if I add 1, I would have a 1 divided over something, which again is a very small probability, but at least non-zero. The other option is interpolated smoothing. For this you use both your n-gram that you have decided and all the grams before this. In your case, this will be bigrams, so you will make use of bigrams and unigrams. Basically what this means is you have your theta. Your theta is the weight that you give to a certain probability. So if we believe that your bigrams are way more informative than your unigrams, you would make your first theta 1 very large and theta 2 very small. If you believe that both carry the same weight, you would both make them, in this case, 0.5, since all weights need to sum to 1. I believe that this will be on your exam, but mostly in, again, the way that you need to count them instead of probability. If you do have a probability specifically, the probability will be given to you, or you need to count it from a table. So it's still very doable. Then, on regards to tagging, are there, by the way, any questions about the statistical NLP part just before?
Yeah. Maybe you mentioned it, but in the previous formula, what does the V exactly mean?
The V, your vocabulary size. Okay. So let's say I have the words in my training corpus. I am Sam, Sam hates cats. Then you have I am Sam hates cats. Those 5 words are your vocabulary. However, your total length of your vocabulary or of your training corpus is 6. So in this case, this would be different and then plus V. Does that help?
Yeah.
Perfect. Any other? Yes, go ahead.
Yeah, could you go again to the complexity?
Yeah.
So what would it be if we have now the my dog 8? Would it just be 1/1 then?
Sorry, if you have what?
My dog 8. So if we would use it on the sentence, because you mentioned this example, then would it just be 1/1?
For this specific one?
Yes.
No. This is the probability of your sentence. So the probability of my sentence is almost never 1, unless you have your training corpus is exactly your sentence that you want. But in all cases, there will be a difference between your sentence and the training, or your sentence and your original, since as you see here, it's just counting. So counting in this case your trigram, word 1, 2, and 3 occurring in that order, divided over the 2 words, so my dog, occurring together. So it will be in this case 1 over probability of my dog ate in that order. Does that help a bit, or is this a reply to this specifically, or?
No, not specifically.
Okay, does that answer your question a bit?
Yeah.
Okay, good. Go ahead.
So is the order still taken into account for the sentence?
Yes. So basically what you have here is W1 to N is just the length of your sentence. So in this case, my dog ate, if N is of W is 3, the order will always be taken into account because, as you see here, for this one it's for the entire sentence. So in this case you do it on specifically unigrams. So yes, it will be taken into account if you do it by bigrams, but not if you do it specifically on unigrams. Is that clear for everyone? Because I
guess I'm unclear on how to count on the previous slide of
Mhm.
counting. What that means is just the amount of times it occurs in the corpus.
in your training corpus, yes, I do have an example of this at the end of the entire course. So specifically for this as well. But basically, this is the important part to remember, is that for your words occurring, it's for that specific order. So for that specific part. Then on to the actual POS tagging. POS tagging is basically where you have to tag the sentence with, is this a noun, is this a proper noun, is this a plural noun, is this an adjective, is this a verb, is this a verb in the gerund, is this a verb in third form present. You do not need to remember all of those tags by heart. Those tags will be given to you on the exam. As far as I'm aware, it might be that suddenly has a change of hearts and doesn't want to anymore, but I believe they would. This is just basically I have to tag a specific sentence or spot a mistake in a tagged sentence. So in a sentence specifically, you can have many different tags occurring. This basically just means you can have a proper noun, a pronoun, a general noun, a verb in a specific way, in its gerund, in its third form. All of these say something about what is happening to the sentence, or what's happening to that word. That tag carries meaning to that word, and you can also use that meaning to kind of understand what this sentence is. Yes, so in any sentence, many of these classes will occur. I have an example of POS tagging at the end of this course as well, since doing it now would be a bit much. But again, something to keep in mind, these tags are not all unanimous. There are still experts in tagging who disagree on certain parts, which very often comes from the fact that there are ambiguities in natural language. If I tell you, I saw the girl with the telescope, does that mean that I'm a creep, meaning that I looked at her with a telescope, or does that mean that she was carrying a telescope? Though that's ambiguous if you do not have further context. So that is something to keep in mind very often. However, something that you will most likely have in the exam is that simple tagging rules will always lead to a 90% accuracy. So if you have any new system that will have tagging, it needs to be at least, or it needs to have at least a 90% accuracy on the actual new training. For this part, it's just assign the most common tag to the word that you have, and for any word that you do not know, assign it proper noun, and by those you already have a 90% accuracy, which is fairly high. So if you want to create anything and it has an 85% accuracy, you did shit, basically. Because anything with just these simple rules already has a 90% accuracy. If you want to evaluate actually how well you do this, so if you want to know if you get this 85% or 95%, you can use two different scores. You can use your raw accuracy and you use your K-score. Your raw accuracy is basically just out of all the labels that I have assigned, how many are correct. It's not that difficult. A better representation, however, will be the K-score. As for the K-score, you have more context. You kind of see how well it does in regards to a completely random accuracy, or a random classifier in this case. Which is your raw accuracy, which you can calculate above, minus the random accuracy over 1 minus your random accuracy. This is just a score that they use. Yes?
Will the random accuracy be given in the exam, or do we just always say 0.9?
No, random accuracy will be given, since random accuracy is given by a separate, different classifier, which could also have a classification score of, or raw accuracy of 55%. It's just a random classifier which doesn't follow those rules. So, other ways to evaluate this is just by precision, recall, and later also your F score. Precision is just how many of the tags were correct and how many did I do. So that's your true positives over all the positives that you have. So your true positives plus your false positives. So how precise was I? For recall, it's just how many of the entire class that should be classified is how many of the actual class are correctly tagged. So that's true positives over your true positives plus your false negatives. Yes.
I assume you have to learn those
Yeah.
profiles as well.
Yeah, you have to remember these. That's also why I'm explaining what the difference is between the two. So if you do not remember the formula, you then kind of can think back of what is the difference between the two. You do have to know the formula, but keep in mind, one is how precise was I. So if I make, let's say, an incision, how precise was I? Or if I need to make a cut, did I make it more in the correct place, basically. So this one is just all the things that should be true. This is all the things that I said were true. That's the biggest difference. So top is which ones should, or which ones did I say were true. Bottom, recall, is which ones should be true. As I said, yeah, oh, yeah, sorry?
What about the formulas where we have the true and negatives as well? Do we need to know those too?
As far as I am aware, no. But it could be that, for example, he does say something about the negatives. Then you do have to kind of know how to calculate with them. But as far as I'm aware, no, you do not. I have not seen them pop by. However, again, I do not make the exam, so I can't say for 100% certainty. So, for another way to evaluate it is just your F score. Your F score is basically kind of checking how do my precision and recall combine together. Since it's important that, as I said, both of them have a specific thing that they check. Either how many did I classify out of all of them, or how many were truly classified correctly. For this, you use your F score. In this case, I used FB, since this is the official term. Very often, as I say in the next point, you will use the F1 score. But FB basically uses 1 plus B squared times precision times recall over B squared times precision times recall. If you have your F1 score, basically what you will have is 2 times precision times recall divided over precision plus recall. So that's just something to keep in mind. Just know this formula because, again, it will not be given to you. Any questions for the POS tagging? Okay, then on to parsing. Parsing is just basically understanding what is happening to a specific sentence, and very often also trying to see what kind of ambiguities occur. So, as I said before, the POS tags are important to have if you actually want to find relations between different phrases, so if you want to parse different phrases. As I said, ambiguity is a very big problem, which I will also go into on the next slide. But a solution for the ambiguity is just making use of probabilistic context-free grammar. This is just a kind of slight problem, since it will be very computation heavy. Since for this you will need to kind of make all the trees of all the different sentences. I believe that one of the assignments, I think assignment 5, you had to make many different trees and see which one was correct. And that's a lot of work. So again, also creating these will be a lot of work. So it is a solution, but not necessarily the best. But for ambiguities, you have 4 different parts. You have prepositional phrase attachments, so to which phrase does this prepositional phrase belong to? Again, the same thing with I saw the girl with the telescope. Does it belong to me? Like, am I a creep watching a girl with a telescope? Or is it a girl that just walking in a park with a telescope? Another one, which was in the slides, was San Jose cops kill a man with a knife. Did the man have a knife, or did the cops use a knife to stab him to death? I hope not the latter. Another one is verb phrase attachment. So for this one, it's again to which phrase does the verb phrase in this case belong. And one of those is on the slides as well. So a mutilated body washes up on the Rio beach to be used for the Olympic beach volleyball. Do we want to use the body to play beach volleyball, or was the beach used for volleyball? Again, for us as humans, it's very logical, but in regards to reading the sentence with just the syntax or just the POS tagging, you can't really say. Another one is coordination scope. So what is the scope of the sentence? Does this belong to one or multiple people? There was one on the slides as well, NASA executive and astronaut Tim Burden or something, blah, blah, blah. Another one would be Elizardo, HCA, and human selected for this crash course. Does that mean that there are 3 people here, or am I here on my own? Again, for you it's very logical, but for those having the recording and maybe me saying it in different voices would become difficult. Adjectival modifier. Which noun should be modified? Who remembers the one from the slides by chance? Student gets first hand job experience. Do you mean a hand job or a kind of first hand job experience? Slight difference and kind of problematic, especially if you do it in a headline, which was the case. So again, these 4 you should know and also know what they mean. So then you have probabilistic, context-free grammar. It's a mess. You might need to do this on the exam. I would very, very, very much want to give this to you. Do this last. Do this once you kind of have done most of the questions, because this will take time. This is not going to be fun. But for this, you will have all your grammar rules with a specific probability. As you can see here, from sentence, I go to noun phrase, verb phrase with a probability of 1. I'm not going to go down the entire list, but for all of those, there's a probability to where you're going. For all of these lines, all the probabilities need to sum to 1, since again, you need to have a 1 total. This basically just creates 2 different things. In this case, you have people eat wood with cutlery. Does this mean that they eat wood and the wood has cutlery? Or does this mean that they eat wood and they use cutlery to eat the wood? That's the difference again. So this is again the ambiguity that we just talked about, the prepositional phrase ambiguity. The one with the highest probability is most likely and therefore probably the correct interpretation. It could be that the less likely one is the actual meaning, but again, this is dependent on the context, and this one, as you can see, is context-free grammar. Do people understand this? Okay. For the next one, dependency parsing. Dependency parsing is something that has been on the slides, and it is, in my opinion, not the most fun, but it's a vibe. You have your shift reduce parser, and that consists of 3 different things. You have your buffer, your stack, and your partial dependency tree. These 3 basically just create, in the end, a dependency between the words in your sentence to create something that makes sense and has a complete parsing that should be correct. This one is dependent on context. For this, you have 3 different transitions that you could go into. You have the part where you could shift, so this basically means move the frontmost words from the buffer stack. So this is something that you do before you actually continue. So you just shift it, and then you look at that specific word. You could create a left arc, lark, which is creating an arc from the topmost word to the second topmost word, because you then depended on that. This removes the ladder, so therefore the second topmost from the stack. And they have the right arc, which does the exact opposite, where you create an arc from the second one to the topmost one and remove the topmost one in this case. If you want to evaluate how well this thing did, there are 3 options. You have the exact match, the unlabeled attachment, and the labeled attachment. Exact match is not that difficult. Is it entirely correct, or is it not? If you do this for multiple sentences, you could have a probability that is somewhere between 0 and 1. If you do this for one sentence, you could only have 0 or 1, because you're doing it on one sentence specifically, and everything needs to match. If you do it on multiple sentences, it could be differing per sentence. Because, for example, the first one could be true, second one could be false, third one could be false, and then you have a 33% accuracy for the exact match. For the unlabeled attachments, it's just how many arcs are correct. You just check the arcs, you don't really care about the head or anything in regards to those labels. For the labeled one, you do check the labels and the arcs. That's the difference. For example, for unlabeled attachment, it could be that you have a higher accuracy than for labeled one, because the arc is correct, but the label is not. Then, capturing meaning. This is something that is very often dependent on context, so very often after your parsing. Meaning basically is something that you want to represent or kind of talk about. This is very often done with the signifier and the signified. The signifier is the symbol and the signified is the item. In this case, if I give you the word tree, that is the symbol. And if I want to refer to a tree outside, you know that I'm referring to the concept of the tree, the signified, the item. What you can do is you can make this, you can do this via synonyms. Synonyms are interesting, they work. However, they are very memory heavy, need to be updated consistently because, again, languages develop as well. And it's very subjective. What I find very synonymous could be very different from other people. That is a problem with language since it's very, very subjective. What we can do, however, if we have these things mentioned in a larger network, is we could use the cosine similarity to check if it's actually also good. So the cosine similarity is just basically checking how close are these two. This is for real valued vectors, so not for a one-hot vector. So a one-hot vector is basically you have 0, 0, 1, 0, 0, 0, etc., etc. You only have 1, 1 somewhere and the rest is zeros. For real vectors, real valued vectors, you could have values somewhere in between 0 and 1 and have them over the entire vector. I am very sorry, but you will need to know this formula. It looks like a mess, but it is kind of logical. You basically just need to combine the two vectors and then divide them over the length of the two vectors. This was also in assignment 2, I believe, or 3. No, this was later. Assignment 5 or 6, one of those two, I think. But it should be online, I believe, with solutions. So if you have trouble with this, please check that one. I do not have an example on this specifically. One thing that you do need to keep in mind is this last 3 lines. If your cosine is in the end -1, these are exactly opposites. This means that they are antonyms. If they are 0, if your result is 0, you have a decorrelation, they're orthogonal. And if they are 1, they're very, very similar, so a super synonym, if you will. So basically, if you're somewhere between 0 and 1, they're more similar, they're more likely a synonym. If they're somewhere between 0 and -1, they are more antonyms. This is something that you can just kind of put somewhere in the back of your mind and just remember. Then, for distributional semantics, this is again based more on context. Oh, yes, go ahead.
For the case where the cosine similarity is 0,
Yeah.
is it generally the case for most words that have no shared meaning, or?
Depending on what kind of model you use, yes. However, it could also be that certain words where we do not necessarily add logical connections could have a non-zero probability, because very often it's very unlikely to have a complete cosine of 0. However, it's then often very close to 0. Yes?
In the assignment we were also asked about the angle. Will we be asked about that in the exam?
Don't know. My assumption is no. Again, my assumption is most likely that you will have to know these 3. So if you have a specific angle, you also know what the cosine value of that angle is, and then you know if they are logically antonyms or logically synonyms. I think that is the kind of most important part to remember, and then for the actual angle, most likely you just put that into the cosine and then have this. So, then for distributional semantics. Again, as I said, it's dependent on the context, so it's dependent on the entire surroundings of the words. How large you want this to be is dependent on what the person wants. So if you want to train your entire distributional semantics model, you can make your fixed window size a lot. You can make it 1,000,000 if you want to, but that does mean that you will check a lot of words that are not necessarily related to a sentence. Because I could say many, many sentences and many, many words, but that does not mean that the last sentence is related to the first sentence I just said. This is your fixed window size. Your fixed window size could be 1, so then it's only dependent on the word just before and just after. It could be 2, then it's dependent on the 2 words before and 2 after, etc., etc. Very often, I believe this is put not higher than 15, but I could be wrong with this. But it's most likely, again, so you don't have a too large gap, but you do kind of have some idea of what the entire context is. Models such as Word2Vec are very nice for this. They actually do this for you. They give you a pre-trained model and you can actually use this. These are self-supervised, and also these basically, as I said, train by looking at the context window, so the fixed size window that either the trainer or you have decided yourselves, because you can also train these yourselves. The thing is, if this is great, if this is correct, perfect, you don't need to do anything. If it's wrong, you need to update your weights, because again, this is just a model. If the you can have two different ways of training this. One is you check specifically, you block out the word and you check for the context outside it, and then check if your word that you predicted is correct. Or you can do it vice versa, where you only have the word and predict the context of it. Those are two different ways of training. There's not necessarily one better for the other, depending on your task. The optimization for this is logically done via optimization function or objective function. What you want to do with your objective function in this case, next slide, is basically minimizing it. If you minimize your objective function, you maximize your likelihood. The thing is, you do not know if there is an optimum. So let's say I have a graph that kind of wiggles twice. You do not know which of the two is the best. So for this, you can't really maximize, but you can, however, minimize your objective function. Since you said that yourself, you know this. The gradient in this case is going to the ascending part. So what you need to do is you need to minus it. In this case, you will get your next theta equals your current theta minus a learning parameter times the gradient of your current value. The minus part is important, since the minus part is again going to make sure that you go in the opposite way of the ascent of your gradient. This has been going wrong many times. That's why I'm highlighting it. So keep in mind, if you need to calculate this, it's a minus, not a plus. Then, for word embeddings, all of the things that I just explained before are basically just also kind of word embedding models, where you look at the context and such. This is very fun, apart from the fact that words that are polsemic are not captured. The word bank could mean anything. I'm only looking at the context of it. I'm not looking at the meaning of this specific word. So if I'm talking about a river bank or a money bank, the model doesn't care. It just has the word bank and gives a probability to it. So this is something to keep in mind. Polsemy is not captured by these models. Another thing is that in natural language, we don't have the algebraic structure. So I can't really say, oh, I have 2 times Christmas, or I have 3 times Easter, 5 times King's Day or something. Or what would happen if I add Easter and holiday, or king and holiday. But in models you can. You can add king and holiday, and then you will most likely get something similar to King's Day. In language, this doesn't really make the same sense, as we don't have this algebraic structure. And then, as I said, it captures the context but not the meaning. So if I'm talking about a river bank or a money bank, I don't know, I don't care. I'm only checking those. It captures only the similarity in the context for this. So I know this was fairly quick. I apparently did it in roughly an hour-ish, but that is everything you need to know for NLP. Yes?
What do you think will be in the exam about gradient descent?
Most likely what you will have to do is, what will be given to you is your current value, your learning parameter, and the objective function. And then you would need to use the or the gradient, depends on which one of the two. If it's your objective function, you would need to still derivate it, and if it's the gradient, you need to plug in your current value of theta in there and just use it. Go ahead.
To what extent are the questions about the PCFG?
There will be, I think, at least one of them. So I would say, if there is one of them, if you spot it, just ignore it. Just go for the next one and get there in the end. I do have an example of it at the entire end of these examples. The reason is mostly that if people need to leave, it's probably just 1, maybe 2 questions out of the, I believe, 50? So then you just, let's say, miss 2 of those points. I would say that's better than working your ass off for 15 to 20 minutes on one question and getting those 2 points compared to the others. However, this is completely up to you. If you want to do it in order, go ahead. I would personally just not advise it, since it will take up a lot of time.
And maybe a question, so what proportion of the questions would typically be calculation and what just logic?
The entire exam, I believe, is split into a third for everything. You will have one third which is more memory based, whereas indeed, for example, they will give you a question, what does this mean, or what part is this? The other part is more context, so you need to implement / execute, and then a third is more calculation and mathematics. So it's a third of all, I believe. Again, could be that it changed a bit, but roughly that division. Any other questions? Do people want a short break and then continue with the example questions, or do people want to continue? Because I think talking for another hour would be a bit intense for also you. Break? Okay, then let's have a break. For me, it's now, let's continue at 12 then, which is roughly 10 minutes-ish. Okay, so we are currently just over half the slides I have. So we also have some examples now. As most of you know, the exam is multiple choice. What this means is that you will be able to also just guess whatever you think it is. The only slight issue with this is that one or more answers could be correct. So this means that, for example, 2 answers could be correct, which means that you need to select 2 answers. This will not be given in the question. It will just be stated at the start of the exam. For all questions, there is at least one possibility. So this means that I did the same in my questions. So, which of these strings / strings is or are not in the language L, where L is being represented by this regular language, or regular expression, basically? Go ahead.
I think B and D.
Okay, can you explain to me why?
For the first one, it starts with a B, and then it's AB. It should be like A B A B, so as many A's as B's. So
Mhm.
it can be because it has 2 B's.
Mm-hmm.
And for the D, it has 2 C's, which is impossible.
Yes. Any others? Like, could A or C be in there? But okay.
I think a shorter way is saying it has to have a C at the end, so that's already not B. Right?
It doesn't have to.
Oh. What is
The
it?
question mark refers to 0 or 1 C's at the end.
Ah.
So it could also be none. But indeed, in this case, it is exactly as you said, B and D. Since ABC could be created in multiple ways, just by this one or this one, and then ending with a C. And since it's a star, you could have 0 or more occurrences for this one, and then you could have a C. Then my question is, would the empty string be accepted by this? Perfect. And I saw a hand.
Yeah, I was still confused about like the dollar sign at the end. And like
So you have the hat. The hat means start of your string. It's a delimiter. So let's say I want to check for words that start with, or I already tokenized all of my things and I only have words now, and I want to check for any word that starts with the letter Q. I need to use the kind of hat. Because otherwise, what would happen, a substring would also be selected. So for example, if I want to have any word that starts with a Q, I would get question and Q and such. But if I don't, I would, for example, also get the word that is concatenated as waiting queue or sub-question. And that is not what I want in this case, since I only want want words that start with the Q. The dollar sign does the exact opposite. I need to have words that end with certain things. So let's say I want to check how many plural words I have or something. I could make sure that it needs to end with an S. Anything before that doesn't matter, and how many letters or stuff is before that also doesn't matter. I only find it important that it ends with an S. This is in this case not necessarily complete, since I also have words that end with an S that are not plurals, but this is just a simple example. Yes?
So I understand that part,
Mhm.
but then say I remove the dollar sign and the hat, will D also, will not D, will B also be accepted?
Both would be accepted.
Why would D be accepted? Because there's still only one C, right?
Yes, but since I do not delimit it to the end of the string, the last C can be ignored. Any part of this substring matches this, because AB also matches it. Just one A also matches it. This means that it needs to match the entire string, not just parts of the string. So basically, if I remove the hat and the dollar sign, it would match all of these.
Okay.
Since I could have 0 or more occurrence of A, B, and C, and all of these have at least one occurrence of all the letters. Then I have the exact opposite question. Instead of having to select which words are in there, I have you make a regular expression, or at least select one. So, which of these is the shortest regex that matches all and only strings that have at least 2 B's at any location? Feel free to just read it, and I will check in a second. Go ahead.
I would say A.
Okay.
Because we have definitely 2 B's that can be surrounded by the letters A, B, C.
Mm-hmm. And why, for example, then not, let's say, B or C, because that one is shorter than A?
With B, we could also accept strings which only have 1 B.
Mhm.
That says we have to have 1 B or more. And with the second string, there cannot be A or C in between the B's. That also makes sense.
Perfect. Yes. Go ahead.
Am I correct in saying that A and C are the only ones who have 2 B's for sure?
Yes. So indeed, for both A and for C, you at least know that there are 2 B's. But the addition of in any to location or in any location makes it A. In D, you could have 0 B's, since you could have A, and that would be an accepted string. So all the other ones have flaws. In this case, that just makes it easy. All the other ones have flaws, meaning it should be A. It could also be that there is another string which I give to you, for example, the entire string of A, but then with a plus mentioned at this B and a star mentioned at the other B, or sorry, a plus mentioned at both B's, which makes it longer, still correct, but longer, which would then make option A still the shortest and most correct one. In this case, there's only one answer that's correct. In the previous one, there's 2. Keep in mind that on the exam, if there is, let's say you believe that there's 1 correct, only answer 1 of them. If you answer more than the amount, let's say there are 2 of the answers correct, and you answer 3 of them, you will get 0 points. If you answer too many, that means that you will just get no points for that question. So be sparse with your questions, because if you answer 1 of them, but there are 2, you still get some points. I believe you were first.
But the plus after the B, right, it wouldn't add anything because I already can add an infinite amount of B's because of the ABC star after it, so it would literally be the exact same regex, or am I wrong?
Oh, you know, it would be the same regular expression, but the difference is that it's longer.
But if that option was added, then I would still only pick A, right? Because
Yeah.
they're asking for the shortest.
No, indeed, but that's why I kind of said the other 3 have flaws, which means that it's easy to check. But it could also be that another regular expression is correct, but it's longer. So that's why I want you to check all of them.
How does the at any location work?
You mean the first string or in general?
Or in this case, I don't really see the difference. Why A is correct because of at any location and not C.
So C is not correct because for C you must have two B's back to back. You must. There is no other option. So I can't have, for example, BCB, which is a correct string, but is not accepted by C. But it is correct, is accepted by A, since I could have the first B, then any of the middle ones, just anything, so a C and then another B. But for C, bye-bye, you could only have, let's say, BCB indeed, but then ends with BB, or start with BB. There must be B's back to back, which is not required by this case.
Okay, and by shortest you mean literal short?
Yes. So shortest just means the least amount of characters, and
Yeah.
and still correct. That's an important part. Any questions about these? Yes.
But with C, it's also that you cannot have BB, right?
No. In this case, no.
So this would also be a way of checking this.
Yes, it's mostly in this case I just created or added some flaws to all of them apart from A. But indeed, you also would not accept just BB since there's a plus at both the other ones. Any other questions about this one? Perfect. Then let's go to the Levenstein distance, the distance matrix. So, what you do is you have your source and you have your target. Your source is your first column and your target is your first row. This is always the case. This is just something that you have to use. For your zeroth step, you always want to just fill in these two columns. For your first step, you want to fill in the second column and row. The way you do this is just using the assigned values. In this case, I assigned 1 to all of them. So I just said all edits have a cost of 1. So deleting, insertion, and substitution all have a cost of 1. Could someone tell me what then would be at this position? Just right next to the E and in the column of the hashtag. 6. And let's say what would be to the right of the O still in the column of the hashtag? So this one? 2. This is the first step. It's literal just doing it. It's no brain cells, just do it and then you have it. If the cost would be 2, you would have 0, 2, 4, 6, 8, 10, 12. Since again the cost will be multiplied by 2. If it's 3, multiply by 3, etc., etc. For this, you do need to do nothing apart from being able to do kind of basic math, being able to do 0 times something, 1 times something. For the next part, you need to iteratively update your entire thing. So, what would be this value?
0, 1.
I hear a 0 and a 1. Could both of you explain to me why?
Well, I'm going from C to C. I changed nothing.
Okay, and why the 1? Sorry?
Never mind, true.
Oh. So indeed, basically what you check is what do I need to do? Do I need to insert, delete, or substitute something? Do I need to make a change? I go from C to C. I need to make 0 changes, meaning 0. Now I have 2 added corners, because again you need to check for all your corners. For the next one, what would be my value in the row of C and in the column of R? So the top question mark. Go ahead.
1,
Why?
because we add R
Okay, we add R. And how did you get to that specific one?
from C to CR.
Yes.
We insert.
So you always start from your lowest possible option. In this case, that's 0, because you could also go from 1 or 2, but from 0 is the lowest possible option. We go to the right, we insert something, and then you get 1 there. Same goes for going down. You, in this case, delete something since you delete the O, and then you get 1 is there. 1 there as well, sorry. You always want to look at your lowest cost in this case. And since you have 0, 1, and 2, this is your lowest cost. So you will go from there to any other cell. Same goes for these three. If we had a 0 here and here, it doesn't matter which one we take since both are 0. You just take the smallest value you have possible. So you get 1 for both cases. And for this we continue, yes?
Would that change if the costs would be different? So if we had a cost of 4, for example, of inserting?
Yes, then it would change. You always want to take the lowest, newest value. So you always check for the lowest possibility, which in this case would be 0. So it would be logical to go from there. However, if insertion has a cost of 4, as you suggested, the top question mark would become 4 if we start at 0. But let's say substitution has a cost of 2, it would become 3. So then 3 would be the most optimal one. So then you have the smallest minimal value again. Yeah?
Insertion was left to right. Or
Yes, since again your target string is your first column. So there. Sorry. Yeah, the first row. I keep mixing them up myself. But this is your target. Okay? We now ended up there. Woo. Where is it? There. Can I do that? Wee. So, could people tell me what to fill in where? Let's say I want to now know what's in the row of C and the column of A.
2.
Why?
Because 1 plus 1 is the lowest option.
Let's say 2. Oh. Oh. Does it? I'll just do this. It was working just before and now I'm crying. Love this. Don't mind the very beautiful writing in this case. Perfect 2. So what would be here? What would be in the column of R and then the row of O? 1? Why? 0 plus 1. 1. Perfect. I love writing like this. Can I? Ooh. Maybe this is easier. Sorry, we tried it with just a touchscreen and then it worked. So please bear with me. Yes. So. What would be there, like in the column of C and the row of U, while I'm trying to move this? You can also just shout in the meantime. 2. It's gonna be a sideways 2 because why not? Oh. Again, I love this. This is going great, guys. Love this. I was prepared on doing it on the whiteboard, but the recording would not work on the whiteboard, so. Well, good enough. So, then, what would be here? Hello?
3.
It's not working. I'll just, again, do this. 3. So, for all of these, it's not necessarily too hard. What is this one?
2.
2. Sorry, I think I'm in the way. It should be a 2. It's something. Okay. But what would be here then? 2. What would be here? 3. Again, this is just the iterative process that you have to go through here, because you have to go by it corner by corner, because otherwise you don't have all the information about the surrounding things. 4. 3. Keep shouting. That makes it easier. 3?
2.
I heard a 3. What did the other? Sorry? It is a 2.
Oh, no.
Over there?
2.
2. I'm just gonna listen to you. I'm not even gonna check what's happening. Over here? 4. I don't know what that is, but let's say it's a 4. Over here. 4,
3.
3. I'm just gonna continue listening to the first person. If people disagree, you need to shout.
3.
3.
3. 5.
Yes, I see a hand. Give me a
I
second.
have a question. Isn't there like a pattern in this? Couldn't you just,
It is.
yeah, just every time in the diagonal when you add one, for example,
As in you would just go diagonally and add 1
as
consistently?
you, for example, you start at the top left,
Mm-hmm.
and then you add up one to the right and to the bottom,
Yes.
all the way, and then you go to the next diagonal, the 0 there, and then you add up.
You want to say
Yeah,
1,
then
2,
you-
3, 4, 5, kind of.
No. You go to the second 0 there, and then you go to the right again, add up one to the whole thing, and then go to the bottom again, add up one.
Nope. The reason is there are ways to kind of have it be different. You could kind of do it something like that. However, the thing is mostly that this corner at some point also gets some more information because you need to get here in the end, like there. You could do it the way you just described. However, the difference is that there are also edit matrices where you in the end have where, for example, it is, let's say indeed here, it's like 1, 0, 1, 2, 3, 4, 5. But you could also have 3, 4, 3 here in the end. I believe there is one in the assignment where you have a multitude of repeating numbers, if you get what I mean.
Yeah.
Go ahead.
Well, for example, say I want to do the column or whatever you are at now, right?
This one?
Can I just say the one next to it is a cost of 3 for changing crash into co, so I can just say co into crash would be adding one, it's one more, and I can just look at what the previous, like I can say it's become that,
But why would you shortcut this? Because it's not too difficult and you might make mistakes by trying to get a shortcut.
well, how else would you know what the previous step was just by looking at these numbers?
Oh, that's a question I had as well. But you can get to the same word in multiple different paths.
I am personally at the moment a bit confused by the specific question,
The
but
question is when you finish the whole thing,
Mhm.
you can backtrack how you got there.
yeah.
But now you, in the end, you will have a 4 surrounded by more 4s. So which
Yes.
4 do I pick?
Well,
Multiple. There are, or is that the question, if I understand correctly?
not mine, but
Oh,
Okay.
sorry.
fine.
Because what is your question then?
Mine is more like the U as compared to 4, right? That column. I can see that as the cost of turning crass into co, right? Into COU. So I can just say that for the one next to that, I can just say I see it as already being COU or
Then you have this, and you now want to create crash from it. Is that what I
Yes.
understand?
like because I can see I already have crass at
Mhm.
the one before that, so I have to basically just compare that to the next one, right?
That
Or
is indeed-
that how I'm supposed to see it?
That is indeed
That's
the.
the part that always confused me about this, that I have to backtrack everything, but
No, basically, what we're now doing is you have COU and you want to make crash from it. So basically, every single step you take. So let's say I want to take this step. You ignore all of this.
yes.
But if you then want to figure out what this part is, you kind of ignore all of this. Because you only check at your corner. Again, you check the corner and from there you figure it out. This is indeed an iterative way. There is indeed a way to kind of try to speed it up for yourself. However, as nicely highlighted, this makes sure that you do not necessarily make a mistake. That is kind of the important part. Because I could also just, by looking at this string, by both these strings, see what the cost would be. However, it could be that I make a mistake and do it wrongly. For these simple ones, it's not necessarily hard. So on the exam, you could also do it by just checking the strings. This is just kind of the official way that also has been taught by the course, so that's why I'm doing it. Do people want to continue filling this in, or do we now already want to know what this is? Because if we want to know what this is, I want to hear it from all of you. Do we want to continue filling it in, or just have this?
I think it's 4.
Okay, I hear a 4. Do I hear other numbers? Who thinks it's 4? Who thinks it's 5? Who thinks it's 3? Who thinks it's 6? Okay, well, it's 4. In this case, we have multiple ways to actually get there, as also highlighted. Continue filling this in will also show you that for certain parts you do not need to change anything. The S is already there. We do not need to do anything with it. We can just go there and then insert it. Or substitute the E for the H. You don't necessarily need to change it. Same way here for your C's. You don't need to change anything, so you do not have a cost change. There are multiple ways to do this. I highlighted this one because I like it most. So basically, I have my C, I then delete my O, I delete my U, then I keep my R, then I insert an A, I keep my S, and I substitute my E. Yes?
At your U and then A, you have 3, but shouldn't that be 2?
From where?
From U and then A.
U and then A. There?
Yeah, because you have a 1 to the...
Yes, that should be a 2. Correct. That is then a small mistake. That should be a 2. Good spot. Can I put that in here? Can you edit notes while you're presenting? The answer is no. I'll make sure that I update it before I upload it to or I send it to the SC for the crash course. But basically there are again multiple paths that you could take, because you could also just say that you substitute multiple things and then keep them in the end. I personally just like this path most, so there is no necessarily wrong way as long as you can show what your path is and what which one you took. So, then for the next one, are there any questions about this, by the way? Okay. Now for the next one, I have some POS tagging. So this is tagging, you will most likely get this. This is not the complete column and the complete overview of the Pen Tree Bank tagging. This is just a smaller one. This is probably the one that you will get on the exam, at least that's my assumption, since then you don't have to do the complete all the tagging super exactly. You will most likely get longer sentences than this one. So please check which tags you think should go where, and then I'll check at the end.
What is IBM in the example?
Where? Oh, IBM, that's Investigative Bureau of Management something? It's just a name.
Okay.
If someone has a feeling they know, go ahead and raise your hand or just shout it.
For the first one, I thought I is a PRP.
Okay.
And then I wasn't sure if this was a verb base form or verb non-third person singular, but I think it's that one, second. So
Mhm.
the VBP.
Mm-hmm.
Then A is a determiner. In is a I skipped one. In Nijmegen is a preposition. In. I skipped multiple. There's also a determiner. And then the study is the noun.
So does everyone agree, or do people have different things, or?
I had Nijmegen as a proper noun and I didn't hear that.
I wasn't there yet.
So if I
What was Nijmegen?
Nijmegen is now classified or tagged as a proper noun. NNP. Anyone? So could you just give the tags in order for now?
Me?
Mm-hmm.
PRP, VBP, DT, NN, IN, NNP.
Does anyone have anything different? Yeah, go ahead.
I have follow VB. Why is it VB?
So you have verb base form and you have verb third person singular present tense.
I can motivate why.
You could indeed both of you motivate why?
It's not the full verb to study, it's I study. That's why I think.
Mm-hmm. And for you?
So I'm not sure what is third person singular.
So you have third person singular and non-third person singular.
So I would say I am first person singular.
You are non-third person. Third person, so you have I is first person, you is second person, and he, she, they are third person. So
Okay, so it's VBP.
it is VDP in this case. And I see a hand?
So what's this about follow?
Follow, yes.
And it's not base form?
No. So in this case, it is indeed exactly as you described. It is a VBP since it is about I, since I follow. So basically what happens is follow is changed due to the fact that I is preceded by it. In our normal languages, it doesn't really change because it's still the word follow. However, in regards to the actual dependency that's there, it has changed to non-third person singular. And it's in the present tense, since otherwise it would be I followed. Yes, go ahead.
You have determiner as that, but there it is DT. I'm not sure if that matters.
Oh, no, I just used DET because I kind of made an oopsie. Because I believe in the other one it was DT or DET.
In the assignments it was.
Yeah, so I just used that one.
But I also have one question about the second question.
Mm-hmm.
Because I don't think train is like, how do I put this,
I do have to say we're not there yet, so I want to first ask people to kind of, did everyone already do that one?
Yeah.
That's kind of the thing mostly, but. So who already did the second one? Please raise hands to make it easier for me. Okay, good. Then I'll give the others a minute, and then we'll go to that one. And then you can ask the question. Okay, who's still working on the second sentence? Okay, then let's continue. What was your question?
So I have all the tags, but
Mhm.
I train ticket to me feels like one word, one singular noun,
Mm-hmm.
but it's two separate words, so I have to
Yep.
classify it, in which case I would say, okay, fine, I make an adjective out of train, but in a way that feels wrong, because
Okay. So what is your current tagging for the entire sentence?
NNP, VBZ, PRP, VBD, DT, and then I'm hesitating on what to do with that, like,
Are there more people who have both the current similar thing, as in you said, NNP, then
NNP, VBZ, PRP, VBD, DT.
okay, and who has the same up until that point? Who has something different? Okay, what do you have, both of you?
Is Tom not a proper noun?
So what would you classify it as?
Tom would be an NNB.
Okay,
Which is what
that I believe that's also what has been said, but could be wrong.
Was just, okay, sorry.
No, no worries.
I think it's a proper noun.
As in Tom, or what is? I don't know which part you're referring to with not a proper noun. So
No, I use not. Yeah.
okay. So up until this point, everyone has the same thing. Yes. Okay. And then for the latter, you were unsure if train was an adjective or
Well, I feel like train ticket in total is a noun,
so you.
but I can't converge these two words.
Nope.
So now I'm like, okay, so it's a type of ticket and the type is train, so maybe it's an adjective train.
Okay. Who agrees? Who also has this tagged as a J, I believe. Yes, adjective. And who said your other option was as a noun, right?
Well, no, I can't call it a noun here
Okay.
because it's tagged as two separate words, but to
Mhm.
me train ticket feels like it should be treated as one word. That is my issue.
Okay. I see a hand at the back.
Yeah, I'm also unsure, but I would probably go for a noun.
Okay. And why would you go for a noun?
It doesn't feel like an adjective.
In this case, it is indeed a noun. The reason is, you are correct, it is a ticket. However, the adjective part in this case is a noun. And the important part is it's not a small ticket, it's not a red ticket, it's a train, which is a noun ticket. This goes for all the taggings. So if you have a noun that is used as a modifier, so for example, a train ticket, a wool sweater, that is classified as a noun. The reason is in the Penjate
Is wool
wool, because otherwise you have woolen,
oh.
and that is an adjective.
Uh,
Yes.
can the Dutch people assume that if you would write it as one word in Dutch, you could see it as a noun?
I can't say for all words or for all cases, but that could be a way to kind of try it, yes.
Okay.
It's indeed, in Dutch you very often concatenate compared to splitting them. So it's also in this case important that the word really changes if I remove train. It changes kind of the meaning as well, whereas with small or large, it is still kind of a ticket.
Was it though? It's still a ticket.
It's specifically for the train in this case, which is a very different ticket than, for example, for a flight ticket, which then specifies it way more specifically compared to a large or a small ticket, which is still a ticket and can
But
kind
then
of be
flight-
generally used.
Flight ticket is an adjective, but an airplane ticket is a noun.
You both of them would be classified as noun, since you can have a flight.
Okay.
So that's in this case. So, any questions about this? Okay. For the next one, calculate the precision and the recall for the nouns. I have told you I will not give you the formulas, since that will also not be on the exam. Who remembers them?
I remember them, but
There was
Please,
I don't
please,
have
ra-
it.
please raise hands for those who remember precision. Okay, and please raise hands for those who remember recall. Okay, could someone tell me then what is the formula for precision without checking their notes? Go ahead.
No, I think it was true positive divided by true positive plus the false positive.
Sorry, the latter part I didn't hear. The true positive.
True positives plus the false positive.
So true positives over true positives plus false positives.
Yeah.
Okay. Anyone agrees or disagrees? No one wants to say anything? You can just say yes, I agree, or no.
I agree.
Thank you. I hear one agree, so that means 100% correct in agreement. So yes, it is indeed true positive over true positive plus false positives. Recall. What's recall? Go ahead.
It is out of everything that is correct, what I predicted to be correct. So it is true positives divided by true positives plus false negatives.
Anyone agree?
Yes.
Anyone disagree? And it's true. You need to know these. I will not be there in your exam saying, what do you think it is? Do you agree? So you will need to remember these. They're not necessarily difficult to remember if you kind of have this side note indeed of how many are correct out of the ones that should be correct. So, with this, what is the precision and what is the recall for nouns? I will give you some time and I'll leave the formulas on there. Who's still working on it? Okay, then please. I heard that no one was still working on it. Oopsie. Let's say I haven't heard a lot from you. What is precision? Yeah.
Well, it's the true positive is 33,
Mm-hmm.
and the false positives are 33 plus 5 plus 2.
Okay, and then what is
So-
your precision in the end?
33 divided by 40.
Okay, and that would roughly be, did you check? Or okay.
No.
0.825, which is roughly 83%. So again, in the exam, they will most likely give you 4 options and then say you need to round to the nearest integer. So they, let's say, give 83%, they give 50% and all of those. Then, for the recall, what is the recall?
33 divided by 33 plus 12 plus 3.
Which comes down to,
33 divided by 48.
yep, which is 69%. Recall is 69%. Very fun. So again, this is not difficult. You do need to know this formula since they will be on the exam, I'm very certain. Any questions about that? Okay, engramming. This is something you had to do during your assignments as well. Could someone pre-process the sentence for me?
Both sentences?
Not just this string then, correction. Go ahead.
Hashtag the cat ate the fish eels. Hashtag the fish that it ate.
Perfect. This is it. It's not necessarily that difficult. You need to just change them and put everything into lowercase. So, you have this, and then my question is, how many unigrams do we have?
Different or total?
How many unigrams? I'm not asking for anything else right now. Go ahead.
Can you get a question about like what the correct pre-processing method is? Or
There definitely could be. It could be that they say, is this string processed or pre-processed or anything like that correctly? Which of these is done wrong? I would say all of those. Sorry?
There's 10 unigrams.
Okay. And all of those kind of. So there definitely could be. I don't make the exam, so I can't say. I heard that there are 10 unigrams. I see 2 hands. Go ahead, either of you. 8? So I hear 8, 10, and 13.
How do you get
Are there any different numbers from these?
It's because, like, the start and end of the sentence are just to give you a clarity on how the sentence is structured, but the words in themselves are unigrams. The cat is a bigram. Hashtag the is not a bigram, so why would hashtag be a unigram?
Okay. And then I heard 8, I think. Similar reasoning, different reasoning.
Different reasoning.
Could you explain it?
Hashtag is a unigram, I think.
Okay.
So the and the in capital and the in lowercase are the same
Mm-hmm.
because we processed it.
Okay.
And when I counted,
Okay.
I got 8.
And I think I saw a hand from you as well.
Same.
Same. Okay. In this case, it was indeed 13, since I did not ask for unique unigrams. For unique unigrams, and that was indeed the specification you asked for specifically, unique would be different indeed. But for general unigrams, you just need to check how many you have. How many bigrams do I have?
12.
Because?
It's always one less.
Perfect, thank you. You don't even need to check. It's always -1. For unique ones, you do. For just bigrams, trigrams, etc., you don't need to do anything except for count unigrams. After counting unigrams, you have all of those combined. If you then make pairs out of it, you will not have your first one specifically separate, since it will be combined with another one, and then all the way at the end. So you kind of skip the first. So indeed -1. The same goes for trigrams, quadgrams, etc., etc. You just -1 every single time. So once you have this, don't continue counting, just continue with it. Yes?
Why does the hashtag and the EOS count for the unigrams? Usually it's just the words, right?
Nope.
I've never seen this in any assignment treat.
There was. In the assignment, there was as well. Some people did it wrongly indeed. Both the EOS, end of sentence token, and the hashtag are unigrams. The reason for this is that at some point it could be that you want to use them for something else. For example, you want to check, let's say for probability, how often it is that a sentence starts with the, or that a sentence ends with died or with fish. So then it's important to know if it is at the end of a sentence or at the start or somewhere in the middle. So it is important for probability in this case. So then we get to the unique ones. So unique engramming. How many unique unigrams do we have?
8.
It's a big surprise. All there. And how many unique bigrams do we have? Okay, why do you get to 7?
Because they're all unique, and there are 7 total.
They're not all unique.
Which ones are the 6?
The fish happens twice. And
Oh, I wasn't looking at the whole
hashtag
sentence
the
anymore.
happens twice.
Okay, so I saw a hand at the back as well, and also here at the front. I don't know, is this in regards to this, or?
Yeah, what was the proposed amount of unique?
I heard 7, if I recall correctly.
It's wrong.
Apparently 7 is not correct, I heard, from a very reliable source. Yeah, go ahead.
I'd go for 9.
Okay. Anyone agrees, disagrees? I think I see a hand is very low, but
I'd go for 11.
for 11?
Go for 10 because you said
Hell yes! So this is what I included. Go for it. Why?
because you said that there were 13 unigrams, that the bigrams are one less than the unigrams, and I know that hashtag the and the fish are repeated, so -2.
But don't shortcut. Just
For the unique engramming, you can't shortcut. For the normal engramming, you can, but I hear that now 2 people agree with 10, and just to give you the heads up, it is. So in here you can kind of see that you do have 10, since indeed the fish occurs twice, so it's not unique. So all of those, that happens more than that, so you then have non-unique ones, and in regards to uniques, you then have the 10.
Hashtag the also appears twice.
Yeah, so that's indeed also then removed from the unique one, so then you have indeed 10. So this is why I give you this example, since as you see, many people have many different answers, but there's only one correct one. So keep in mind, if you're doing this, to be very, very careful with it. And for the n-gramming, just the normal ones, you can shortcut. For the unique ones, you do need to really check. Since, as you see, many different answers create many different problems. Sentence probability. Same thing. If I do not pre-process it, I won't be able to do anything with it. So, in this case, you do this. And I'm not going to bring you to have to do this for all of them, since it's not that difficult. Just remove it like that. What is happening here? Sorry, I got confused by the keyboard. So I just concatenated all of them into one string in the end, so you should see those bullet points as just a continuation of there. However, for this one, since this will also be in the exam a bit separately, we will not make use of the hashtag and EOS for the probability, since at your exam you will just be given a table. For this one, I wanted you to do this because of this table. This table was made by hand. It could be that I give you these words and then you need to do it yourself. In that case, you're indeed correct. For such small examples, we will not make use of the hashtags or the EOS. However, we do need to pre-process it because we also need to make sure that everything is lowercase in the cases it needs to be. On your exam, you will most likely be given this table. If it's not, you need to do it as we did here. You have your first word, followed by anything else. Yes. 1, 2, 3, 4, 5. Yes. So, your first word is your first column. Your second word is your next column. So, let's say I want to have the probability of cat given the. What would be the probability of this? How can we calculate this? Does someone know? If not, completely fair, we're at a crash course, so that's why I'm asking.
Count all the instances where cat follows the
What do we
divided
round
by
it?
all the instances of the.
Indeed. So, if you recall correctly, it's the counting of the words that occur in that order divided by the counting of just that specific part before it, so the given part. In this case, that means count up all thus, all the occurrences of the. In this case, this entire first row, and have that as your bottom part. At your top part, you want to have the part where you actually have the, which precedes cat, because that is the question.
So it's. But isn't it the cat and not cat the?
No, because probability is the question is the probability of cat given the.
So cat given the is already there.
Yeah.
Then it's the cat, not cat the.
It's basically what is the probability of cat following the.
Yeah.
Yeah.
Basically that.
Oh, okay. Yeah. Yeah. That's what I thought, but I heard it differently.
Oh, sorry. It's a need. What is the probability of the cat occurring
Yeah.
when we know the is present?
Yeah.
Could someone other than you in this case give me the answer?
2/5.
2/5? Because
Because the word the appears 5 times no matter what follows it, and the cat follows the word the twice.
indeed, so you get 0.4, 40%. And then for this one, it could be given in both cases, both instances could be a question. So it could be that they say calculate this or calculate the probability of died given sadly, which basically means the same thing as above, but then written differently. Could someone tell me? Yeah?
1/3 because I followed, or sadly followed by died appears once and sadly appears 3 times.
Indeed. So you have 1 divided over 1 plus 1 plus 1 equals 1/3. Now we do it for a sentence. This is going to be fun. How do we do this? Anyone know? It was highlighted in this crash course. How do you want to do this? Yes, but there's an... Yeah, go ahead.
I think define it all in words, so probability of the times probability of cat times probability of sadly, calculate it all and then the logarithms. And
Subtract probability of cat following the plus probability of sadly following cat, etc.
Okay, so
That but multiply the probabilities.
so indeed I hear now log space, I hear multiplying, but indeed the biggest thing is the Markov assumption, the bigram approximation, which you highlighted. Indeed, you specifically do it by only checking the word just before. So the bigram approximation is always the case if you want to check for sentence probabilities in this case, because it's just way less computation heavy. In this case, I do not make use of log space because this example is super small and I did not feel like it. That's the only reason. Go ahead.
You also multiply by the probability of the at the start of the sentence?
Would you want to?
I guess, because that's kind of important.
No, in this case not, since in this case you only make use of the bigram. In this case you do not make use of any unigrams. If you want to have interpolated smoothing, you do. But then you do it for all the bigrams. So for sentence probability, you only check for your bigram approximation. So you kind of skip the first word and you only check for all the bigrams occurring afterwards. So in this case, that would be 3 bigrams. So what would be the probability of the cat sadly died?
1 over 15.
1 over 15. Anyone agree, disagree? Yeah, go ahead.
I agree.
Thank you. Anyone as well? Any other people? Anyone still working on it? Cat given the is 2 over 5, sadly given cat is 1 over 2, and died given sadly is 1 over 3. Multiply all of these together and you get 1 over 15. This is also the reason why I didn't use any logarithms in this case, since I was like, I know these probabilities because I made this example, I don't need it in this case. If you do, you can, but in this case I was just too lazy to do it. That's the only reason. I think you were first.
So if we have the fish ate the fish, would it count as one occurrence or would it be two?
No, it occurs twice. You have the fish, then occurs twice, since it is in that order of the sentence. So you then multiply it, so basically you square fish given the.
So my question was basically,
Yeah,
the
it-
question was if we just check if it is in one sentence
Mm-hmm.
or if it can occur multiple times. in
It
one
occurs multiple times because in the sentence it occurs multiple times. You have a question as well?
Will we ever be like obliged to use logarithms in the exam?
If they say so. Honestly, that's basically the case. It sometimes says, because I remember from your assignment 3, it was said, do this in log space and do this in non-log space. If that is given, you must. That is how it works. I can't make it kind of easier or more difficult than that, unfortunately. Okay, then we have this. I now have a dog. The dog didn't exist. I need to use Laplace smoothing. How do I do it? Does someone remember what Laplace smoothing is? Go ahead.
The probability for dog following the is now the probability of the at the bottom part, but plus 1, I think, because there's a dog added as well. Wait, no, just the probability of the, and then the top part is 1 because we just add 1 for everything that didn't appear, I think.
Okay, I saw a hand at the back as well. Did you want
Just add one.
1 everywhere? So would that change anything in regards to other things? Again, by the way, keep in mind, this is now how we do it. Important part, indeed, we add 1 everywhere. However, we also need to add dog to our new vocabulary. So we add that dog as well, since it is now a new word. So, boop. If I add dog, I get this. This is now my new thing. Dog has never occurred in this way, so I need to add it like that. However, if I want to use Laplace smoothing, again, keep in mind our new numerator and things change. I need to add 1 everywhere. So I will need to recheck the lengths of both. So for example, in the previous case, I believe the denominator would always if I would just use Laplace smoothing, be 6. In this case, it would now become 7 since I added a new word. This is the only difference. You kind of just add one everywhere and then just continue with your life doing the same thing as we did before. So, same question. What is the sentence probability of the dog sadly died? Is anyone already finished with it? I believe this is the last example before we get to probabilistic context-free grammar. So it's also 1 o'clock at that point, so if people want to leave at that point, feel free. Afterwards I will shortly go into probabilistic context-free grammar to mostly show people how it works. If you feel like you understand or you do not want to be there, completely fair, and then have a great day. So is there anyone done with this smoothing probability example? One person?
I think so.
Okay. Who is just sitting there and not really feeling like doing this? Also completely fair, please raise hands. I have one, I have multiple. Okay, so who is still working on it? Okay, so you were the first to raise your hand. What was your answer?
The probability of the dog
Mm-hmm.
is 1/12.
Okay.
And then multiplying that again with the other, or then we have to calculate the probability of not attending,
Okay.
It's 1/7 for all the others, so you get to 1/588. That was the hardest part to calculate.
Okay, and I think I saw another hand. I don't know if you had something. Okay, so indeed the first one is 1/12. I'm just going to show all of them all at the same time. So for dog following you indeed have the same thing. The 2 plus 3 was already there, in this case plus 7. The 7 is mostly because I just did all of these, my vocabulary size. So basically just plus V. That's my new vocabulary size. That goes for all the others. So dog, sadly following dog is 1/7 since dog never occurred, so then it must be 1/7. And then died given sadly in this case was sadly given there. So you have the 1 plus 1 is that. So you multiply all of them. 1/12 times 1/7 times 2/10 equals 2/840. It equals 1/420, which is roughly 0.002. Any questions about this? Okay.
These numbers on purpose.
Hmm?
Are these numbers on purpose?
Could be. I really don't remember. I made most of these slides last year. So then the probabilistic context-free grammar. This will kind of be a bit more intense. So I would say let's just have a 2-minute break. For those who want to, you can leave. For those who do not feel like it, feel free to stay, go to the toilet, grab some water. And was there a question about this specifically?
Before for the smoothing, are we going to be asked for good Turing smoothing?
Sorry, could you...
Good Turing smoothing.
good Turing smoothing?
The thing in the lecture been going over, so.
For the Turing smoothing, I don't remember. There could be that you have to do the interpolated smoothing. And then you just use the unigrams just before it. But I would say let's have a 2 to 3 minute break until 1:05. And for those who leave, have a great day. Good luck with your exam, and see you next time. No worries.
There are two formulas that go on the slides. Both refer to language but I didn't see the difference. Like both la clase is la clase. They're quite similar, but I'm not sure is this one refers to migrants or this one refers to immigrants or
That one refers to immigrants.
okay. So we
Plus you have an agency exists over all unigrams. So that should basically that's the only
yeah, okay, perfect.
no worries. No worries. I think so. Everything until this point should be recorded as far as I'm aware, and otherwise the slides will be uploaded. No, I am doing parts of it on the whiteboard, but I can try if I can do it here. It's just writing is a hassle on this thing, so that's why. Yes, there most likely will be. On parsing, I believe there will be multiple questions. I can't say for certain times, but I believe for the fancy parser there will be. Good luck. Okay, so let's quickly continue with this and then go into the weekend hopefully carefree. So for this, the probability sentence is in this case. We have the sentence, people eat wood with cutlery, the same one that I used earlier in the slides. So people that have a great memory, you do know the actual answers. For people that kind of forgot or were like, nah, that's not important, have fun. You need to do this by heart. So the question is, which of the following probabilities corresponds to the preferred parse tree? And in this case, that would be a multiple choice answer. I just let you do it by hand because you need to beforehand anyway. So we have the sentence, people eat wood with cutlery. What do we have to do? Does someone know? If not, completely fair. Yeah, go ahead.
You just have to follow the tree and then do the probabilities times each other in succession. So like you start like, okay, I know I start with an NP.
Mm-hmm.
My NP is a noun, so O.6. My noun is wood, so O.6 times O.1.
Mm-hmm.
Then I get my VP, and my VP is a verb NBVP, which is O.6. So the O.6 times O.1 is now also times O.6, which we then go to verb, first verb.
I'm going to quickly stop you there for a second. You are indeed on the right track. However, I would say for people who do not really know what is happening, this is a bit intense. I would very much advise you to first check what your entire sentence should be tagged as, since that is kind of easy. You can see which words you have and which words are, in this case, in your entire grammar. For example, I know that people and wood and cutlery must be a noun. It says right here that it must be. Therefore, I can classify them as a noun. Same goes for eat, same goes for with. We know what this is because they are terminals. Those are final and those are given. Nothing will change afterwards. This leads to a specific structure. This structure is then noun, verb, noun, preposition, noun. From this, you can indeed, as you highlighted, create your tree. I would say for this one, it's just easy to first have it. First, check what are your terminals, what should they be, and then highlight that as your structure. Once you have that, you can go for the other ones. Because now that we have it, we can check which connections can be made. So we see that if we start at S, so your entire sentence, we must have a noun phrase. And for the noun phrase, we see that there can't be any verb afterwards. Because, as we can see in NP, nothing says verb in here. So that means that we, in this case, must go to the noun, meaning that we already have the first part of it. After this, we have the VP. The VP, the verb phrase, can go two ways. It could either be just the verb, the verb with a noun phrase, or we could have the verb with a noun phrase with a prepositional phrase. So those two are the two different trees that we could have. If we go further, I believe the next slide should be the same. Yeah. So if we do that, we could create this tree. We have two different trees. We have the one where we have people that eat wood with cutlery, since that's just a dish apparently, or we have people that eat the dish wood and they eat it with cutlery. Those are the two things. From this point onwards, you just need to follow indeed the steps as you said, follow your specific tree. In this case, that would mean that if you have your sentence, you start with S. Well, we know that that must have a probability of 1. So you have 1 times the rest of your sentence. For the second part, we know that noun phrase in both cases will go from noun phrase to noun to people. In both trees, that's the same, both the first and the second one. Therefore, we know that we can do 0.6 times 0.2, since that is just given. For the next part, for the verb phrase, this is where the distinction will be made. We can either go into the first one, so the verb with the noun phrase, which has a probability of 0.4, or into the 0.6 probability where we have a verb with a noun phrase with a prepositional phrase. Let's skip the second one for now and let's only go into the first one. We now already have 1 times 0.6.0.2, since that's given. Then we have the second part for the verb phrase. If we go into the verb phrase, we want to go into the verb noun phrase, which has a probability of 0.4, as you can see right there. If we have that, we then need to check what goes on further. If we go there, we have the verb. Well, the verb has a probability of 1 of going to eat, so times 1 again. The second part is the noun phrase. For the noun phrase, we would need to have a noun followed by a prepositional phrase, as you can see in the parsing tree. That has specific probability of 0.1. So then you further multiply by 0.1. Then you have the n, the noun, which has a probability of 0.1. Since in your NP it already says first have a noun, then your prepositional phrase. So this part is already given. You go into your would, which is 0.1. You further multiply. For your prepositional phrase, it always has a probability of 1 of having a preposition and then followed by a noun phrase, which means times 1 again. For your preposition, you see that all prepositions are with, meaning that again, multiply by a probability of 1. Then you have your noun phrase, and this is important. You go into the noun, 0.6. You do not immediately go to cutlery, you first go into noun. So 0.6 times 0.7, and that results in this beautiful calculations. I am also now showing the other one, since going into an extra one is just an annoying hassle. Do people understand what we just did? Do you think you could do this yourself on the exam? Will you cry if you see this on the exam?
No.
I hear a no and I see 2 people nodding, so let's hope only muffled cries, otherwise you bother all the others. No, it should be fine. But basically for this, it's just annoying. As you see, it just takes time. It's not necessarily difficult, but you need to be careful, exact, and it takes time. So that's why I'm telling you, please skip it at first and come back to it at the end. Question at the back.
Is the tree given, or do you need to like also choose the tree? Or?
You need to make the tree yourself. That's why I started with this. Let me check. Oh, sorry, I went too far. That's why I started with only this. Because if I start with this, you need to make everything yourself. So that's why I say kind of the step guide. First, go to your terminals, determine what those are. Therefore, you have your structure, you know what it must be. And then check if there are multiple trees possible. If there are not, you will know, you can just easily calculate the probability. If there are, you need to check which probabilities you have. You always go for the higher probability since it's more probable. So therefore, if you, for example, have, let's say, 4 answers, since it's almost always A, B, C, D, and one of them has the highest, and you see that your probability is, for one of the 2 trees, is lower than that, you do need to calculate the other one to check if that one is higher. if your first answer already is the highest probability given, there is no option for going higher than that. This is just kind of a side trick thing to indeed shortcut it a bit for yourself, but I would say if you have time, calculate both trees and see which one's highest. You had a question?
Yeah, I was gonna ask, like, does it matter, like, will both trees have the same probability, or are they really gonna screw you over, but you already answered that?
Well, look at this. They do not have the same probability. And if I would be an annoying teacher, spoiler alert, I would give both these answers as options. Because once you have calculated one of them, that doesn't mean that the other one is true. Since you have 4 options, so 2 of them are not even possible, and the other 2 might be possible, and at least one of them must be possible. So
So you just have to pick the highest probability and do all trees. Okay, that does make it more annoying.
Yeah.
I now understand. why
that's
you say
indeed
it
also
is
why I say
hard.
do this at the end, since it's at least 2 trees. Because otherwise, at least I would say there are at least 2 trees, because otherwise you can just immediately do all of it. So with this, I am done. I hope it helped. And are there any further questions about NLP? No? Then I wish you the best of luck with your exam and have a great weekend.